Let's look back at the previous sequence. Say, for example, we have right 2, 3, 6, 11, 18, 27, 38, 51, 66, so on and so forth. Now, let's look at the difference here. This one, 3, 5, 7, 9, 11, 13, 15. So we have difference of successive odd numbers. Remember the formula, the general formula of this uh, sequence. Just take the first term, which is 2, plus n minus 1 to the 2. So we subtract 1 so that when n is 1 for the first term, this term of this expression becomes 0, so we have 2 as the first term. Now what if the sequence is given like this? Say we started from 18. Let's say 18, 27, 38, 51, 66, so on and so forth. Now suppose we didn't have knowledge of this one, and we do as usual. We look at the difference of the sequence. So here we have difference is 9. Here we have 11, 13, we get 15. Now we look at it, it's 9, 11, 13, 15. So it's an odd numbers. That means we have the rest of the odd numbers here that started from 1, 3, 5, 7, then it gets to 9. So what are we going to do with this one, since we didn't start from the first odd numbers? But we still have to consider this, and the idea is if we want to use the first term of our sequence, which is 18, then we need to do something else. If we take all the formula of n minus 1 squared up to here, then we're considering all of this and all of the cumulative sum. So what we're going to do is we subtract this sum here. So what is that sum? This sum is, okay, 1 plus 3 plus 5 plus 7. The sum is, it's 10, 16. That's 16. Now one way to look at this when our sequence is very large already and it's difficult to sum this up, so we can look at this formula, S equals n over 2. The first, this one is the first term of our odd numbers plus the last term of our odd numbers, which is let's say L. And we have, now we still need to express this, what n is this one. So if you look at what n is this one, you need to look at this formula, 2n minus 1. 2n minus 1. Okay? So since this is 7, it's equal this to 7. So we move this here, it becomes 8. So n is equal to 8, and 8 divided by 2, so n equals 4. So that's how you solve how far is the odd number is using this formula. Now our n is 4, so we have 4 over 2. The first term is 1, the last term is 7. So we have 2, this is, hold on, first term is 1, last term is 7, and over 2, that's 8. So we get 16. Oh yeah, it's correct. So it matches here, 16 and 16. So that's one way to look at it using this formula if the sequence is very large and it's difficult to uh, add it by inspection. So you can use this formula instead. Okay, let's go back here. So that's 16. We're going to deduct this by 16. Now our formula here should start from n, right? Where we start from n equals 1. And since our n here is already at the 4, we passed already the fourth one. So to make this 4 here for a general n for this term here, for the term of 18, so we need to add 3 to make this 4. Okay, square. Okay, then you see it's still of this form, except that we need to come up this one to 4, right? If your n is 1, so this is 4, so you have the fourth term minus 16. Okay, so that when your n is 1, then it's gonna be 4 here. 4 squared is 16. 16 minus 16 is 0, so our first term is 18. Hence, let's check it out if this is really true. When our n is 2, okay, n is 2, so it's gonna be 5. 5 squared is 25. 25 minus 16 is 9, and 9 plus 18 is 27. So it's correct. Now we can simplify this. It's gonna be equal to 18 minus 16, that is 2 plus n plus 3 squared. We can expand this more, but I will leave it like this. Let's look at to the other sequence where the differences are even numbers. Say, for example, start from 3, add 2, 5, add 4, 9, add 6, 15, add 8, 23, add 10, 33, add 12, 45, add 14, 59, add 16, 65, add 18, it's 83, so on and so forth. So as usual, the first thing we do is to find out the differences when we're solving sequence like this. So let's find this out. It's 2 here, this is 4, this is 6, this is 8, 10, 12, 14, 16, and then 18. Now, the formula of finding this type of sequence will be, we get the first term, which is 3, plus, okay, for the even numbers, if you take the cumulative sum or the series of these terms, we have n n plus 1. But since we need to start from 3, so we need the first term to start here at 0 when n is 1, so we have to subtract 1 here. So n minus 1 is n minus 1, and n plus 1 minus 1 is n, so we have n and n minus 1. So that when n is 1, so this one is 1 here, this one is 1 minus 1 is 0, so it's 0, and we begin at 3. There you go. Now suppose the sequence didn't start from 3. Suppose it started from 23 instead. So the sequence like this, 20, 23, 33, 45, 59, 65, 83. Now, at first, okay, we assume that we don't have the knowledge of this one. Okay, we only given this sequence. So first we have to find out the differences. This is 10, this is 12, this is 14, this is 16, and this is 18. Now, if you look at it, it's even numbers like 10, 12, 14, 16, 18. So that means we still have the previous even numbers here, like 8, 6, 4, 2, that are excluded in the sequence. Now, to write the formula, we still have to start with the first term, which is 23. And then we add the whole term. So if we had the whole series of these even numbers, it's gonna be okay. Now there's a kick here. If you look at this one, what term is it? Okay, so we still have to look at this one. We need to add all this because we're going to subtract this here. Because what we're going to do is to get all the cumulative sum here, and we subtract this cumulative sum of the previous. Okay, so that we get this part, sum of our even numbers. All right, now let's add this. Okay, the cumulative sum of this difference is 2 plus 4 plus 6 plus 8 is equal to, that's 10, 10, that's 20. Okay, that's pretty easy. You can look at it here. But in case the differences are very large number already, like it's very far already, it's difficult to add manually. So what we can use the formula S equals n over 2, the first term plus the last term of our even numbers. Now here, for this part here, our 8 is, that is, since this is even, that is 2 2n, right? Like 2x. Okay, use another form, another variable. 2x equals 8. That means our x is equal to 4. Okay, let's use big N instead. Okay, so our N is 4 for this part. Okay, so use a big N here. This is 4 over 2, and the first term is 2, the last term is 8, so this is 2 times 10, and that gives us 20. So this is the formula we use for large numbers already, and it simply matches the sum. All right, now we start from 23, and let's look at here first. So we need to use this form here. We need to add that one here, except that we this one here will sum up to 4, and this one will become 5. So that means this term here. So to make this equal to 4, when n is 1, we have n plus 3. This becomes 4. Okay, and then this one, n minus 1, n plus 1, and n minus sorry. So actually we're using this formula here. This is the general formula that we're using. So it's gonna be n plus 1. So since our n is n plus 3, so n plus 3 plus 1 is n plus 4. Okay, so when your n is 1, this is gonna be 4, this is gonna be 5 here. 4 times 5 is 20. So this is the uh, general term, okay, for all the even numbers here, differences of even numbers. Okay, and then since we started from here, we need to subtract this one, which is 20. Subtract the 20 of all the cumulative sum. Okay, so finally we have this form. Okay, we can check it out. When your n is 1, this is 4, this is 5 here, this is 20. 20 minus 20 is 0, and this is 23 for first term. And when your n is 2, it's going to be 5, this is 6, 5 times 6 is 30, minus 20 is 10, so 23 plus 10 is 33. We get the correct terms. Alright, next thing is to simplify this. We have 23 plus, that's n squared plus 7n plus 12 minus 20. So this is gonna be 23 minus 20 is 3 plus 12 is 15. Okay, I'm gonna write it like this: n squared plus 7n plus 15. So this is the general formula of this sequence. You want to try it out, like 1, 2, 3, 4, 5. Let's take 5, the fifth term. Let's check it out. So when the n is 5, we get 25 plus 35. 7 times 5 is 35 plus 15. So what is this? This is 50, 60, 60, 60 plus 15 is, wait, where's the fifth term? 1, 2, 3, 4, 5. Okay, it's the fifth term. There's 25 plus, okay, so we're gonna have 50, 60. and this is 75. Something wrong here. So 59 plus, oh, sorry, this one should be 75, okay, plus 14, plus 16 is 75, and then plus 18 here is 93. Okay, I made a mistake for the sequence. There you go. Okay, let's apply that to this sequence really quick. Now let's check the differences first. So this one is 63, this is 65, this is 67, this is 69. So as we can see, the differences are consecutive odd numbers. Alright, now if we get the general formula, we copy the first term, which is 8, then we add the consecutive sum of the odd numbers, and then we subtract it by the previous terms, okay, or differences that we're going to take away from here. So what is this differences? They are 61, starting from 1 up to 1, okay? So before we get into 88, we have 61 here as the differences. Now, how to get this 61? Because what we're going to do here, this one here is the sum of these consecutive odd numbers. So we need to get this sum, which is given by s equals n over 2. The first term, which is of course 1, and the last term is 61. But here we don't know the n yet, so we cannot get the sum of these consecutive odd numbers. However, to get the n of 61, let's use the formula of odd numbers. The n terms of the odd numbers is 2n minus 1 equals 61. Now, going to solve for n here. We have 2n equals 62, so that makes our n equals 31. Okay, that's the value of our n. Now let's plug it down here now. 31 over 2. This one is 62, and if we multiply it, we get 961. Okay, let's go back to our formula. So going to subtract 961 to is consecutive, or the cumulative sum from 1 to 69. Okay, but I want to n, okay, so this goes up to n terms. So now we have to make sure that this is 31 here, because 961, if you notice it, it is 31, and divided by 2, 62 divided by 2 is 31. So that's actually 31 squared. So this is 31 squared. So we have to make sure this is 31 squared. Okay, 31 squared will stop here, and then the next term will be 8. So to do that, this must be n plus 30, because our n is 1. We get the first term. Okay, this will now become 31 squared minus 31 squared. First term will be 0. I'm sorry, 8. Okay, we can now expand this one. We have 8 plus n squared plus, okay, that is 60n plus 900 minus 961. Okay, so this is now n squared plus 60n n. Okay, this is negative 61 plus you get 50, negative 53. Okay, this is now the general formula of this sequence. You can verify it if it's true. I will verify the next one only. When your n is 2, you have 32 squared. And 32 squared is, check it out, is 1024, and it's subtracted by 961. We get 63. 63 plus 8 is 71. So it's correct for the second term. You can verify the rest of it to find out this really holds for all the terms.